Hello everyone, this is BSc third year class. Complex analysis
that we have started yesterday. This is our paper 14.
Complex analysis. Today we are going to start our first chapter of this course. Unit first, complex numbers.
This is our unit first, complex numbers.
In this chapter, we are going to study first sum and product of complex numbers.
Sum and product of complex
Numbers. That is, we are going to discuss how the sum of two complex numbers is going to be done and the product of two complex numbers is going to be done. So, before we will start this unit first, you must know what is meant by complex number. Now, consider one polynomial of degree 2, x square minus 1 is equal to 0. So, in set of real numbers, we can factor this polynomial linearly as x minus 1 into x plus 1 equal to 0. Hence, if the product of two real numbers is 0, then any one of these 0. So, this is equal to 0 or this is equal to 0. X minus 1 is equal to 0 or x plus 1 is equal to 0. This implies that x is equal to 1 or x is equal to minus 1. For this polynomial, the roots of this polynomial belongs to R. So 1 comma minus 1 belongs to set of real numbers. Now consider another polynomial. X square plus 1 equal to 0. So this polynomial we cannot split in the set of real numbers. And to find the solution of this polynomial, we need to introduce complex numbers. So x square is equal to minus 1. But we know that in set of real numbers, there is no real number whose square is negative. So this polynomial has no root in the set of real numbers. So x is equal to in square plus minus in square root minus 1. X is equal to plus minus I. So value of the I is in square root minus 1. So I square is equal to minus 1. So this is a complex number. So polynomial x square plus 1 can be written as x plus I into x minus I is equal to 0. This implies that x is equal to plus minus I is the solution of this polynomial. And we need complex number system, that is complex field, to factor this polynomial linearly. Also note that complex number is big field than all fields. That is, set of rational numbers, it is a subfield of set of real numbers, it is a subfield of set of complex numbers. So this field contains all fields. So this is the universal field because the set of complex numbers contains all fields in the mathematics. So every field is a subset of complex field. So we can write every field is subfield of set of complex numbers, and set of complex numbers is denoted by symbol this. Set of complex numbers is denoted by symbol this. Now, Generally, the complex number is denoted by complex number is denoted by z is equal to the tuple x comma y, which is equal to x plus iy. So generally complex number is denoted like this, where x is equal to real part of z and y is equal to imaginary part of z. Here x is a real part of the complex number. Every complex number has its real part and imaginary part. So x is equal to real part of z and y is equal to imaginary part of z. Also we can draw a z plane. So this is imaginary plane, imaginary axis. This is real axis. This is real axis, and this plane is called as z plane. So the point on z plane can be denoted as the point x comma y is equal to x plus iy, can be denoted as on the z plane. So this is x, this is y, this is imaginary axis, this is real axis. So point x comma y is denoted like this on z plane. Now, equality of two complex numbers. When we say that z1 is equal to x1 comma y1 is equal to x1 plus iy1 and z2 is equal to x2 comma y2 is equal to x2 plus iy1. Then z1 is equal to z2 if and only if the real part and imaginary parts are equal. x1 equal to x2 and y1 is equal to y2. This implies that every complex numbers, two complex numbers are equal if and only if their real parts are equal and its imaginary part of equal are equal. So if we consider z1 is equal to 1 plus I, this can be written as 1 comma 1 and z2 is 1 minus I, it can be written as 1 comma minus 1. So z1 and z2 are not equal because their real parts are equal but their imaginary parts are not equal. 1 equal to 1 but 1 is not equal to minus 1. Therefore these two complex numbers are not equal. Now consider a complex number z is equal to x comma y is equal to x plus r. Now we can write this polynomial as x 1 comma 0 plus y 0 comma 1. Thus we can say that every complex number can be written in the linear combination of these two numbers. Also we can write x comma 0 plus 0 comma y. 0 comma y. So this is z. Now here x comma z is called as real axis. Real axis. On the real axis, the coordinate of y is 0 and 0 comma y. This is imaginary axis. Imaginary axis, that is x equal to 0 on this axis. Now, addition of two complex numbers. Addition of two complex numbers. If addition of two complex numbers. If z1 is equal to x1 comma y1 x1 plus iy and z2 equal to x2 comma y2 x2 plus iy. Then the addition z1 plus z2 is equal to x1 plus iy1 plus x2 plus iy2 and real part and its imaginary x1 plus x2 plus y1 plus y2. This can be written as x1 plus x2 comma y1 plus y2. So the addition of two complex numbers is add the real parts and add the imaginary parts. Now product of two complex numbers. Product of two complex numbers. Product of two complex numbers. If z1 is equal to x1 y1 is equal to x1 plus iy and z2 equal to x2 y2, this can be written as x2 plus iy. Then the product z1 z2 is equal to x1 plus iy1 into x2 plus iy. So multiply x1 to these two numbers. So x1 x2 plus x1 y2 plus now y1 x2 I into I square. I into I is equal to I square, which is equal to minus 1. So y1 y2 minus y1 y2. Now real parts of this number take outside. x1 x2 minus y1 y2. I take common x1 y2 plus x2 y1. So this can be written as x1 x2 minus y1 y2 common x1 y2 plus x2 y1. So this is the product of two complex numbers. We have defined addition of two complex numbers and multiplication of two complex numbers. So addition of two complex numbers z1 plus z2 is equal to x1 plus x2 and y1 plus y2. And then multiplication z1 into z2 is equal to x1 x2 minus y1 y2 comma x1 y2 plus x2 y1. So addition of two complex numbers is defined like this. In addition, add real part and imaginary part separately, and the multiplication of two complex number is this. Now z square is equal to z into z. Then z cube is equal to z square into z is equal to z into z square, which is equal to z into z into z. Likewise, z raised to 4 is equal to z cube into z is equal to z into z cube is equal to z into z into z into z. So this is the multiplication of two complex numbers. Now I is equal to n square minus 1. I square is equal to minus 1. I cube is equal to minus I raised to 4 is equal to 1, and I raised to 5 is equal to I. So note that this note value of I is equal to v square root minus 1. If we square both sides, then I square is equal to minus 1. I cube is equal to minus I raised to 4 is equal to 1. I raised to 5 is equal to I. तो आजचा लेक्चर इथंच थांबूया. उद्या आपण ह्याचे काही पुढचे पॉईंट्स घेऊया. थँक्यू.